要问的话，我们就第二个 talk 啊。那第二个 talk 呢，是由这个黄伟燕另外一位老朋友彭杰教授，他将琢磨在这个 Hadronic Physics 这方面介绍这方面的工作。这边没错。他这个好像出的没准没看。好。
So I have to start by apologizing. I'm going to give the talk in English because I think Professor, yeah, okay. Also, I think I talk faster, a little bit faster in English, so it saves some time. Yeah. So I'm very grateful to have the opportunity to come here to pay my tribute to my old friend, Pauchy Hwang. So, as Haiyan mentioned, that this is an autograph of Pauchy, and he actually considered himself having lived 3 lives. So this is the name, and he was very fortunate to have 3 lives. And these 3 lives were really separated by some very important incidents actually in his life, which were presenting some really severe limitation on his physical abilities. However, Pauchy overcame all those obstacles and then led really productive and successful career in science and everything else. So I think it's also interesting that one can separate his research accomplishment pretty much into 3 different categories. The first area is weak interaction and symmetry. We just heard from Professor Jen-Chieh about the work he did while he was a student at Pennsylvania and also Washington. So his mentor actually at that time was Primakov and Handy. So the second area of his research is on QCD and hadron physics. So this covered the period from 1983 to 1999, when he was at Indiana University and also at National Taiwan University. So his role has changed. He now is becoming a mentor for many students. And then this is continued on by the third area, which we'll hear in the later 2 talks about his work in the actual particle physics and also cosmology. So let me start with how I first met Pauchy. So he was already quite famous when I first saw him. I remember that I was attending a meeting at APS. So Pauchy was giving a talk, one session. So I was sitting actually very far away from the platform, and Pauchy was talking with such a deep and magnetic voice. I still remember that. He spoke very loudly and convincingly, and even without a mic. Actually, the chair of that section, which was Joe Relish, was commenting at the end of Pauchy's talk that he forgot to put the mic on Pauchy, and nobody noticed. So the second time I met him was while I was visiting Indiana University in 1983. So Pauchy was very kind to me. He invited me to lunch, and actually he talked nonstop about his research during the lunch. So So I was very much impressed by Pauchy's friendliness as well as his enthusiasm in the physics research. So this led to several visits of Pauchy to Los Alamos. I was at Los Alamos lab at the time. So during the period of 1986 and 1988, Pauchy visited usually rather 1 month visit or so. Okay. The reason he visited us was that Pauchy was collaborating. He's a theorist and I'm an experimentalist. However, Pauchy was collaborating with our experiment group in medium energy physics. He was actually acting as an in-house theorist and also consultant on our Fermilab experiment. We're just starting our Fermilab experiment at that time. Okay. So I think, as you will see later, that our research program really benefited greatly from our interaction with Pauchy. And as a result of this visit, I really got to know Pauchy, Jane, Justin, and Irvin much better. Okay. So let me just briefly mention what were the experiments we were trying to do at that time when Pauchy visited us. We were starting some experiment at Fermilab. Actually, this is equipment which was built by Leon Lederman, okay, at Fermilab. So he abandoned this experiment after he finished his equipment, after he finished his experiments. We sort of took over. So you can see that using this equipment, we actually did a series of measurements. If you look at the title of those measurements, experiments, many of them actually have the name Woei-Yann associated with it. Okay, so as Woei-Yann mentioned, the Woei-Yann process was invented actually by Sidra and Yandong Mao in 1970. This is actually a picture taken from their paper. I should mention that the latest count is that this paper, famous paper, was cited already 1,500 times to date. So this is the diagram they draw actually in this famous paper describing how a very energetic pair of muons can be produced in the collision of two hadrons, A and B here. So this turned out to be a very important process because it played really a very important role in validating the QCD as the correct theory for strong interaction. Okay. Another implication of this important paper is that one can use this process to probe the internal structure of the hadrons. So in this sense, it's complementary to the deep inlet scattering, and one can use this process to probe actually the anti-quark structure in hadron. So that is the introduction of why we were interested in using this process to probe the internal structures of the nucleon as well as nuclei. So Pauchy actually made this very important contribution to this experiment. He was the one who pointed out to us that although this experiment was proposed to use the Woei-Yann process to probe the structure of the nucleon, one can also study at the same time the quarkonium production, okay, from the same data we are collecting. Okay, so this is the work he did with us. So this suggestion actually led to several major publications from our experiments. So you can see that these are the three major publications from these experiments. If you add the citation, they actually amount to about more than 1,000 citations. So these are the results obtained from these three papers. And following Pauchy's theoretical guidance, we actually found that the Woei-Yann process has a very different nuclear dependence compared to the J-side as well as the Wolfson productions. So this result actually was also playing a very important role later on in the search of the quark-1 plasma in heavy ion collision, once using the quarkonium production as a signature actually for the presence of the quark-1 plasma. So as Woei-Yann mentioned that soon after Pauchy returned to NTU, he was pushing very hard for the international collaborations in the area of medium and high energy nuclear physics. So this is a picture taken in May 1988 in front of the academic Sinica. That's Pauchy here. So actually during that meeting, which I also attended, but I think I'm outside of this picture, probably being cut off. So actually, Pauchy actually proposed these ideas of the Taiwan user group. Okay, so I know that Pauchy was very busy actually at the time when he first arrived in NTU, and one of his initiatives was to establish what he called the Taiwan user group to participate in high-energy physics experiment worldwide. Okay, so Pauchy, even though he's a theorist, he recognized the importance of establishing a strong high-energy experiment group in Taiwan. And I think together with support of Liz Chang and Zheng Haiyang, and actually Leon Lederman also wrote a letter in support of this activity. So Taiwan actually became a member of the Fermilab experiment in 1989. So this is actually a picture Fermilab kept about the experiment, I think around 1990, this the experiment we're doing. Actually, I was much younger here, that's me. And there's someone, this is Professor Jen-Chieh actually from Academic Sinica. So we're actually doing the delay of the signals in an old-fashioned way just by using very long cables here. So this amounts to the first, I think, high-energy physics experiment at Fermilab from Taiwan. And these are the results obtained from these experiments. I think this activity initiative actually evolved into Taiwan's participation later on in the CDF experiments, which discovered the top quad. I think it's really Pauchy's idea of this Taiwan user group, which developed in all these later high-energy experiment activities in Taiwan. Okay, so in 1990 to 1991, Pauchy actually received the Humboldt Fellowship. So he spent some time in Germany. So during his visit, I think it's in Jülich, he collaborated with Joseph Spatz and also Jerry Brown. And they wrote this actually quite famous paper. So in this paper, they point out this Meson cloud contents of the proton. Okay, so this paper was actually quite important because it led actually to the later discovery of this large flavor asymmetry of the nucleon C. Okay. So what do I mean by this flavor asymmetry in the nucleon C? So just very quickly, after the discovery of the deep inlet scattering, so everyone thought that the C quark distribution in the proton, they should be symmetric. In other words, the anti-up quark should be the same as anti-down quark. However, later on, actually, it was pointed out by Feynman and Field that they might be different because of some simple exclusion principle. Because the proton, there are two up quark and one down quark. Therefore, the Pauling blocking actually is going to suppress the anti-up quark relative to the anti-down quark. So this is a very nice speculation. However, there was no experimental proof of this idea. So the correct way to find this flavor asymmetry of the nucleon C actually was mentioned in this paper by Pauchy. When he visited us, he was pointing out that one should use the Woei-Yann process in order to find a very definitive evidence of this C quark asymmetry. So this, following this suggestion, this is the measurement we performed at Fermilab, and from this, we are seeing this is the d bar over u bar. One can actually see that as a function of momentum of the quark, one can see clearly that they deviate from 1. Therefore, we observe very clear signature of this asymmetry. So I think Pauchy's work really contributed to the discovery of this large flavor asymmetry. This work, again, led to 3 publications, if you add the citation, among more than 1,000 citations. So this probably one of the more important results we obtained at Fermilab. I think it's really due to Pauchy's work with us, the theoretical guys. Okay, so now let's turn the clock to 1995. I think Professor Woei-Yann and Pauchy actually invited me to spend 6 months at NTU. I think with the purpose of establishing the high energy experiment group here. So I had the opportunity to work closely with Wei-Su and also Pauchy during my 6 months visit. And I really witnessed firsthand the tremendous effort and skill, I think, of Wei-Su in building up extremely successful high energy experiment group at NTU, essentially from scratch. I must mention that the support from Pauchy in this direction, I think, which probably originated from his Taiwan user group, was very essential during the very difficult and challenging early stage of this effort. Okay. So around that time, also Pauchy's interest in the QCD and Hadron physics, I think, was centered on the QCD sum rule. So these are 3 of the highly cited papers Pauchy wrote with Ernest Hanley as well as Leonard Kissinger from Carnegie Mellon. And also with he's very proud of his student at the time, Yang Guizhou, who worked on this subject. So this QCD sum rule is really a rather sophisticated technique which is designed to study some non-perturbative feature of the QCD. So this is just diagram taken from a paper by Yang Guizhou as the first author. And you can see that these are the diagrams they have to deal with in order to calculate some interesting properties like the hadron mass splitting, the meson decays, hadron magnetic moments, isospin symmetry breaking, meson Buchanan coupling, etc. So I think Pauchy actually spent a great amount of efforts actually on this subject. So in 1996, Pauchy actually had an extended visit to Peking University, and he delivered an intensive course there, and which led actually to 6 highly cited publications on the topics of QCD sum rules. So this is the list of the 6 publications within a span of 1 year. I'm just highlighting this bright young student, actually, Zhu Silin. Okay, so he's the first author for almost all those papers. So I also heard Pauchy mentioning his name very often to me. So this actually is the email I received 1 week ago from Zhu Silin, who is now actually a full professor at Peking University. So this is so I think it started by mentioning that how he learned the subject of QCD sum rule while Pauchy was visiting Peking University. And then I think they worked together and went through all these details of calculating Feynman diagrams and so on. So he ended by saying that even though I did not spend too much time with Professor Hwang, and whenever I think of him, I always have a very warm feeling in my mind, and I really wish Pauchy to rest in peace in heaven. So I think this. So around that time, actually, Pauchy's research interest turned to actual particle physics and cosmology, so just around the turn of the century, actually. So essentially, Pauchy spent the last 20 years of his life working on in this area, which we are going to hear in the next 2 talks. So just to, to finish my talk, I would just comment that in 2015, I spent 6 months sabbatical at academic Sinica. So during that visit, I made sure that I will visit NTU every Wednesday so that I will have lunch with Pauchy. So Pauchy usually did all the talking when we had the lunch, as usual, and I would just listen to him. So Pauchy very often talked about his old days with Professor Primakov, as Woei-Yann was telling us. Also about his recent research, and also about his grandiose future plans in life. So at the time, Pauchy also introduced his good friend Sunny Chen to us. We had many memorable dinners together. I'm sorry about the quality of the picture. So this is actually the picture taken during Sunny's retirement celebration in 2016. Actually, I think this is the last picture we took with Pauchy. So these are the concluding remarks. I think all of us will agree that Pauchy was an extraordinary person with great integrity, visions, and also perseverance, determinations. He overcame huge physical limitations and made remarkable contributions as a researcher, educator, and scientific leader. So I think Pauchy will continue to be an inspiration to his many friends, colleagues, and students. And I'm really very grateful for having him as a longtime friend, and I will miss him forever. Thank you.
So maybe some question to Professor Peng. So under him some time. Or if no immediate ones, we are again save to the end.